feel free to pause the video and try these problems yourself. See if you can solve it, and then unpause it when you're done and see how to answer the question, because the best way to learn is by you doing the problems yourself. So let's begin with this one. A ball rolls horizontally off a cliff at a speed of 30 meters per second. Now it takes about 7 seconds for the ball to hit the ground. Our goal is to calculate the height of the cliff and the horizontal distance traveled by the ball. Now for projectile motion, there's pretty much 3 basic pictures that you really have to worry about. The easiest one is if it rolls off horizontally from a building or a cliff, which it looks like this. The other types, let me see if I can draw it here, is let's say if it's kicked off the ground and it goes back down, or if it's kicked off a cliff or some mountain or top of a building, let's say if it goes up and then down. By the way, if you have a question, let's say if it kicks off to the left, it's the same as what we have here. So those are the 3 types of shapes, regardless if it's going to the left or right. That doesn't matter. And throughout this video, we're going to cover each of those 3 common scenarios. So you need to know that the vertical displacement, which is the height of the cliff or the building, that's the height. That's dy, so to speak. dx, the horizontal displacement, is also known as the range. So the range is basically the same as dx. The y is dy. Now, if you want to find the height, to keep things simple, use this equation. H equals 1/2 at squared. Using that, you can find the time it takes for an object to fall down, hit the ground, or you can find the height of the building if you're given the time. Now, for those of you who want to know where that equation comes from, it comes from this. dy is equal to v initial. Well, I wrote it earlier in this video as d is equal to v initial t plus 1/2 at squared. Now we're using it as vertical displacement. So instead of d, we're going to use dy, which equals vy initial t plus 1/2 ay t squared, because it's based on the y direction. Now, whenever you have an object that rolls horizontally off a cliff, this speed, because it's moving in the x direction, that's basically vx. It's not vy. The only time you can have a value for vy is, let's say, if the object is moving up, if it's moving down, or at an angle. You see, here we have positive vy and negative vy. When it's at an angle, it has an x component and it has a y component. But whenever it's moving horizontally, either left or to the right, vy is 0. So there's no initial vy. Thus, vertical displacement is equal to 1/2 at squared, which is what we have here. So that's where this equation comes from. It really comes from this. But whenever you see this scenario where a ball rolls off a cliff or a building, just use this equation. So our goal is to find the height of the cliff. And the time it takes for the ball to hit the ground is 7 seconds. So it's just 1/2 9.8 times t squared, which is 7 seconds squared. So that's basically 4.9 times 7 seconds squared. So the height of the cliff is 240.1 meters. Now some of you out there might be wondering, hey, why don't we use negative 9.8? You could use it. Let's say if height is basically dy. If you plug in negative 9.8, you're going to get negative 240.1. Now, keep in mind, dy represents displacement. What this means is that the ball traveled downwards in a negative y direction by 240.1 meters. So that's what the negative sign really means. But when you describe the height of a building, you're not going to say negative 240 meters. You're going to say, hey, that cliff or that building is just 240 meters tall. So for this particular problem, the negative sign is not important. We can use it if we want, but the height of the building is going to be positive. But at other times, we do want to use a negative value for ay. You just have to use the discretion when you need it and when you don't. If you want the height of the building, it's not important. But just understand what the negative means. It means that you're going down in the y direction. Now the last thing we need to do is find the range. The range is basically the horizontal distance traveled by the ball. Now range is equal to Vxt. Vx is the horizontal speed, which we already know. So basically it's 30 times 7, and that's equal to 210 meters. It's traveling horizontally 30 meters per second every second. So if it's traveling for 7 seconds in the air, it's going to cover a distance of 210 meters. And that's basically it for this problem. That's how you solve it. So what about this problem? A ball rolls off a building that is 100 meters high. Calculate the time that it takes for the ball to hit the ground. So take a minute, try this problem, and then unpause the video when you're ready. So let's begin. So this is going to be my basic picture for a building or cliff. And the ball simply rolls off the building. So it travels horizontally and then it falls to the ground. Here's the height of the building, here's the range. Now for this problem, we don't need the range. We only need to find the time. And we're given the height. The equation that has height and time for this particular scenario is h is equal to 1/2 at squared, which we covered that problem, or we used that equation already. The height is 100 meters, and acceleration in the y direction, we're only going to use a positive 9.8, but if you wish to use negative 9.8, make sure you use negative 100, because the displacement in the y direction is negative 100. The ball travels 100 meters down in the y direction. But either way, the negative signs will cancel, so just know that time has to be positive. So do it in such a way that time will be positive, and you'll get the right answer. So if we multiply both sides by negative 1, this is going to be positive 100 and positive 9.8. Half of 9.8 is 4.9. And if we divide both sides by 4.9, 100 divided by 4.9, that's about 20.408. And so that is equal to t squared. So next, we need to take the square root of both sides. The square root of t squared is just t. Here, this index number is a 2, and the 2's pretty much cancel. So here we have a 1. The square root of 20.408 is about 4.52 seconds. So that's how long it's going to take for the ball to hit the ground. It's going to take 4.52 seconds for it to reach the ground. And that's all you got to do. Here's another one. A soccer ball is kicked horizontally from the roof of a building that's 150 meters tall and lands about 200 meters from the base of the building. Calculate the initial speed of the ball. So go ahead, take a moment, see if you can solve this one. Always draw a picture. So we have another building. Here's the ground level. And the key word is horizontally, so we know the picture looks like this. That's one of the first types of horizontal projectile motion problems that you're going to see. The building is 150 meters tall. So we know the height is 150. Now let me put that somewhere else. And it lands 100 or 200 meters from the base of the building. Here's the base of the building. So it landed 200 meters from it. So that is the range. So we have the height and the range. Our goal is to find the initial speed of the ball. Typically, if they just say speed, you're looking for v. But notice that the ball was traveling in the horizontal direction. Whenever an object is moving horizontally, v is equal to vx. Here's why. We know that v is the square root of vx squared plus vy squared. But if vy is 0, then v is equal to the square root of vx squared plus 0, which is v is equal to the square root of vx squared, which is vx. So v equals vx whenever an object is moving horizontally. So our goal is to find vx. That is the initial speed of the ball. when moving horizontally. So to do that, the way we can find Vx is by using range. We know that range is equal to Vxt. That equation comes from this. D is equal to Vt. This equation is true only when an object is moving with constant speed. Whenever an object has constant speed, the acceleration is 0. And as we mentioned before, the acceleration in the x direction for any object that is defined to be a projectile is 0, which means Vx is constant. So we can use this equation. So range is equal to Vxt. Keep in mind, range is basically dx. Range is the horizontal displacement. So you can replace this d with r. So dx equals Vx times t. Now, we have the range, but we don't know what the time is. So before we can use that equation, we need to use another equation to find time. And so we're going to start by using h is equal to 1/2 at squared. Once we find the time it takes for it to hit the ground, we can plug it into this equation and solve for Vx. So the height is 150. Acceleration, we're just going to plug in 9.8. By the way, this is acceleration in the y direction, since height is vertical displacement, it's dy. So half of 9.8 is 4.9, and 150 divided by 4.9, that's about 30.61, and that's equal to t squared. So we're going to take the square root of both sides. So the square root of 30.61 is about 5.533. So that's how long it takes for this ball to hit the ground. It takes 5.53 seconds. So the ball has been traveling in the air for that long. So now we can use that in this equation to find the initial speed. So the range is 200 meters. We're looking for Vx, and the time is 5.533. So 200 divided by 5.533, that is equal to 36.15 meters per second. So that's Vx. That's the initial speed of the ball as it left the building. This problem might be a little longer than the first three. So a soccer ball is kicked off the ground at an angle of 40 degrees at a speed of 47 meters per second. Find the maximum height that the ball will reach. Second, find the time it will take to hit the ground. And third, find the horizontal distance traveled by the ball. So this time it's not kicked off or rolled off from a cliff or a building. So this is the second type of picture that you're going to deal with. If an object is kicked off the ground, it goes up and then it falls back down. Now it turns out that there are some special equations that we can use for this type of scenario. The angle above the horizontal is 40 degrees. Now the ball was kicked at a speed of 47 meters per second. Now it's good to understand that V is equal to 47 meters per second, not Vx, not Vy. When it's at an angle, there's an x component and a y component. If it's traveling horizontally, all you have is Vx. If it's traveling vertically, all you have is Vy. But at an angle, you have both Vx and Vy. So if you're given the speed at an angle, it's neither Vx nor Vy. It's simply V. So just make sure you keep that in mind when solving these types of problems. So what equation that we can use to find the maximum height that the ball will reach, which is basically this vertical displacement there. Now we're going to try to solve it two ways. First, there's an equation that you could just plug in and get the answer. And here it is. H is equal to V squared sine squared theta divided by 2g. So let's go ahead and plug it in. So the height is basically going to be equal 47 squared times sine of the angle, which is sine of 40 degrees. Make sure your calculator is in degree mode, by the way. And then we're going to square it, divided by 2 times 9.8. And type it in your calculator exactly the way you see it. Don't take any shortcuts. So the answer that I got 46.57 meters for this problem. But now we're going to see if we can get that same answer solving it another way. Now, we're going to define this point as point A, point B, and point C. We want to find the maximum height. So basically, we want to find the vertical displacement from point A to point B. So let's make a list of what we have. At point A, we know what the speed is. It's 47 meters per second. We know the height, which is basically vertical displacement. That's dy. Actually, we don't know the height. We want to find it. Now, we also know the speed at point B, the vertical speed. At the top, Vy is always 0. We don't know what Vy initial is, but we do know what Vy final. It's 0. If we're going from A to B, A is our initial position, B is our final position. The vertical speed at B is 0, so we say Vy final. The acceleration in the y direction is negative 9.8. Our goal is to find vertical displacement. But how do we find Vy initial if we're given initial speed? Now, earlier in this video, we mentioned how to find Vx and Vy from V. Vy is equal to V sine theta. And we have the angle, which is 40. We know what theta is. So that's going to be 47 sine of 40 degrees. And if you type that in your calculator, you should get 30.21. So what equation can we use that has Vy initial, Vy final, acceleration, and displacement? It turns out we can use this equation. Vy final squared is equal to Vy initial squared plus 2AD. We've went over earlier, but we just didn't have the y's in it. We wrote it as V final squared is equal to V initial squared plus 2AD. If it's traveling in the vertical direction, you can add a subscript y to every term. So let's plug in what we have. Vy final, that's 0. Vy initial, that's 30.21, but it's squared, plus 2 times. Now in this case, the signs are important, so let's plug in negative 9.8 and times d. So if we move the 30.21 to the other side, 30.21 squared, that's about a 912.6. But if we move it to the left side, it's going to be negative 912.64. 2 times 9.8, that's like 19.6, but it's negative. As we can see, d is going to be positive. As we go from A to B, the ball is going up. So thus, the vertical displacement is positive. dy is positive. From B to C, dy would be negative. So negative 1912.64 divided by negative 19.6. So vertical displacement, you would get 46.56. Now the reason why it's good to know it both ways, because you might be wondering, hey, why do I need to do it that way if I already know the equation? Sometimes you might find yourself in a situation when you're taking a test and you forget the equation. You might forget to memorize it. But if you understand how to select 2 points in this situation and how to find what you need, you can solve any problem using projectile motion. You can solve like any type of projectile motion problem. So even though there might be an easy way to solve it, I want to show you other ways of doing it so that when you find yourself in a situation where you don't have a simple equation to solve it, you can use your intuition and your creativity to answer these problems. But now there's a lot more that we got to cover, so that was just part A. I don't want to clear away the entire page, just this part. So now let's focus on part B. Find the time it will take to hit the ground. So we still have the same picture. Ball goes up, then it goes back down. Now if you want to use an equation to get the answer, here's the equation you need. It's 2v sine theta over g. So v is 47, the angle is 40. divided by 9.8. So let's go ahead and plug that in. So this is equal to 6.17 seconds. So that's the answer. But now, how can we find the time using other methods? So let's define our 3 points: point A, point B, point C. So how can you find the time? Let's say our goal is to find from point A to point C, but let's find it from point A to point B. The time it takes for it to go from point A to point B is the same time that it takes to go from point B to point C. We just simply have to double the answer. Now let's see what we know. We know that Vy final, the time it takes the velocity at point B, is 0. We know Vy initial. We calculate that to be 30.21 in the last in part 1. We know the acceleration in the y direction is negative 9.8, and we just want to find the time. So you want to use this equation: V final equals V initial plus AT, but in the y direction. So V final is 0, V initial is 30.21 minus 9.8 times t. So if I move the 30.21 on the other side, I get this. So it's 30.21 divided by 9.8. So t is 3.08 seconds. Well, it's like 0.83 if you round it, but if you double it, that's the time it takes to go from A to B. From A to C, it's twice that value. So it's really like 6.165, because this should be like, it's 3.0826. You can round this to 3 if you want. But as you can see, the answers are very close. It might vary by some rounding error, but that's the other way you can find it. This equation actually comes from this equation. If you solve for the time, it's the change in velocity. It's, well, V final is 0, so the time was negative V initial divided by, I guess, negative g. That equals t. We did negative 30.1 divided by negative 9.8. So the negatives cancel. But keep in mind, to get Vy, we know Vy is V sine theta. So it's V sine theta g equals t. Let me put a y here. But now, is there another way where we can get that answer? Is there a way we can try to get the time if we go from point A to point C directly, skipping B? Let's see if we can do it. So let's use this equation: y final equals y initial plus Vy initial t plus 1/2 AT squared. So y initial is 0 because at point A, the position is at 0 along the y-axis. Vy initial, that's V sine theta, we know it's 30.21. So we have 30.21 t, and A is 9.8. Half of 9.8, that's 4.9, but it's negative 4.9 because A is negative t squared. So we have y is equal to 30.21 t minus 4.9 t squared. So this equation can help us to find the time at any point along this graph. We could find the time here, 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 anywhere we want to, provided if we know the height, because we got to plug in y and find the t. If you know the height at, let's call this point E, you could find the time it takes to get there. If you know the height, let's say at point F, you could find the time it takes to get there. But notice that point E has another height. Let's call it G. E and G have the same height. So therefore, there are two answers for time that relates to those 2 points. What we're going to do is set y equal to 0, because at point C, the position is 0. What you want to do is factor out t, and you'll get 30.21 minus 4.9 t is equal to 0. So we have two equations. When it's in its factored form, you can set this equal to 0, that's the first answer. And for the other one, you set what's inside the bracket equal to 0. So we're going to move the 4.9 to the other side. So therefore, we have 30.21 is equal to 4.9t. So 30.21 divided by 4.9, you get this answer. You get 6.165, which rounds to 6.17 seconds. So you can get the answer at C, or any point, by the way. Now notice that there are two answers because y is 0, the height is 0 at 2 points. It's 0 at point A and point C. At point A, the time is 0, so that corresponds to that answer. And at point C, the time is 6.165. So you could find the time it takes to get any point if you know the vertical displacement or the height of that point using that process. So now let's focus on part 3. So we want to find the horizontal distance traveled by the ball, which is dx, or basically range. Now we said that range is equal to vxt, and we know that if vy is equal to v sine theta, vx is equal to v cosine theta. So if you have the speed at an angle, use this form of the equation. We're going to replace vx with v cosine theta, so it's v cosine theta times t. This is the simplest way to get the answer. But there's another equation for range that you can use, which I'll go over as well. So the speed is 47, the angle is 40, and for this to work, we need to know the time, which we already know the time it takes for it to go to point A and C, from point A to point C. It's about 6.156 seconds. So it's 47 cosine 40 times 6.156. So the range that I got, in my calculator at least, it's 221.64 meters. But that's if you know the time. What if you don't know the time? Let's say if we didn't need to do parts 1 and 2. Let's say if the question only wants the horizontal distance traveled by the ball. You don't want to have to go through some long process of finding the time. It turns out there's an equation that you can get the range without the time. And here it is. Range is equal to v squared sine 2 theta divided by g. So v is 47, and we got to double the angles, sine 2 theta. So 2 times this angle, if we double it, it's 80 over 9.8. And just type it in the calculator exactly the way you see it. And you get the same answer. Well, almost the same. I got 221.98. I mean, it's not exactly the same. I know why. I used 6.156. I believe it was 6.165. Because the rounding answer was about 6.17. So that could be my fault. So 47 cosine 40 times 6.165. Yeah, it should be 221.97 if you use this answer. So yeah, these two pretty much are the same. Okay. So that's two ways that you can find a range. If you know the time, just use this equation. If you don't know the time it takes for it to fall back to the ground, use this. So here we have another similar scenario. A ball is kicked off the ground, reaching a maximum height of 60 meters and lands 80 meters away. Calculate the initial speed, v, and the angle above the horizontal of the ball when it was kicked. So the ball is kicked at an angle, it goes up, then it goes down. Our goal is to find theta and the initial speed v. Now we know the height is 60 meters. That's h, or dy, and the range is 80 meters. It lands 80 meters away from where it was kicked. So we got to find v and the angle theta. The best way to find v is to use this equation, vx squared plus vy squared, and the square root of that result. Now, since we're looking for initial speed, we're looking for v initial. So we need to find vy initial and vx initial. But vx is always constant for any object that is defined to be a projectile. So once we find vx, it is what it is. It's going to be vx initial or vx final. They're the same. But vy initial, we can find that. Now, once we have vx and vy, we can find v. And also, we can find the angle. The most common way to find the angle is to use inverse tangent vy over vx. So how do we find vx and vy? So take a minute, feel free to pause the video and see what ideas you can come up with to find vx and vy to solve this problem. Now, it helps if you define your points. Let's say this is point A, point B, point C. It's best to include point B if you're dealing with anything in a y direction. So let's use point A and B. So A is our initial position, B is our final position. We know the vertical displacement between A and B. dy is positive 60. As we go up from A to B, we travel up 60 meters in the y direction. We also know what vy final is. At point B, the final position, vy is basically 0. It's always 0 at the top here. Not vx, but vy. And we need to find vy initial. And we do know the acceleration in the y direction. It's always negative 9.8 for any object in free fall, or any object that is a projectile under the influence of gravity. So what equation has vy final, vy initial, ay, and dy? It's this one. V final squared equals v initial squared plus 2ad simply applied to the y direction. So let's plug in the values that we have. V final is 0. We're looking for v initial. A is negative 9.8 and d is positive 60. So 2 times 9.8 times 60, that's 1176, but negative. And if we move it from the right side to the left side, it's going to be positive 1176, and that's equal to v initial squared. So we're going to take the square root of both sides. And so that's 34.29 meters per second. And it's positive since it's going up. So that's vy initial. So now we need to find vx. The best way to find vx is to use this equation. Range is equal to vxt. However, the only thing that we're missing is the time. We have the range, but we don't have the time. So we got to use another equation to find the time. Now, let's focus on part B to C. If you just draw the half part of this graph, it looks like this. This is point B and this is point C. If we just take this section here. Now notice that we've covered this problem early in the video. This is basically the scenario where a ball rolls down off a cliff. It's basically the second half of the scenario that we have for this problem. And for that scenario, from B to C, you can simply use this equation. H is 1/2 at squared, because it's the same exact picture. We already know the height to be 60, and the acceleration is 9.8. So half of 9.8, that's 4.9. So 60 divided by 4.9, that's like 12.24. And then if you take the square root of that to find t, you'll get 3.5. So that's the time it takes to go from B to C. So now if we want to calculate the range, Vx, it's simply the range, which is 80, that equals Vx, and then plug in t, which is 3.5. So Vx is equal to 80 divided by 3.5, and that's like 22.86 meters per second. But we're not done. There's still some more things that we have to do, but let me just write these answers down. Now keep in mind, this is not the only way in which we can solve for the time. In our last problem, we used this equation to find the total time, 2v sine theta over g. And that would give us a time from, let's say, point A to point C. But if we want to find the time it takes from point B to point C, that's half of that. So for a symmetrical parabola, which we have, we can just use this equation, v sine theta over g. And let's try that. So t is equal to, actually no, we can't use that equation. Well, we could. We just have to realize that v sine theta is vy. So since we have vy ready, we know it to be 34.29. If we divide it by 9.8, notice the answer that we get. You would get 3.5. So there's many ways of solving for a variable that you need. You just have to pick one of those ways. So make sure you understand how these problems work, and then you can find the right way to get your answer. So I just want to show you the other way that another way you can use to find time, if that method is the only way that you can use on a test. But let's continue. So we know that Vx is 22.86, and Vy, that's 34.29. Both answers are positive. So now we can use that to find V, which is the square root of Vx squared plus Vy squared. So that's the square root of 22.86 and 34.29 squared. So if you type that in, you should get 41.21 meters per second. So that's the initial speed v. Now if you want to find the angle theta, it's just inverse tangent Vy, 34.29 divided by Vx, 22.86. And that's about 56.31 degrees. And that's it for that problem. So we have the initial speed v and the angle at which it was kicked.